Hello, my name is Andrew Russ, and I just want to take this time to go over my project for Computer Science 111. It's Intro to Programming at UIC, and in this project we were tasked with filling one of four categories: data visualization, diversity, teaching Python, and then is technology good? I ended up going with data visualization, and for visualization I thought it'd be best to expand on a concept that was already well developed. So you can look on websites like salary.com, Glassdoor, and stuff like this. They'll give you information on what you can expect your salary to be for a given state. So take like Texas, for instance. If I'm a chemical engineer, I might expect to make 75 grand. But if I move over to Alaska, it might be 85 grand. And that's well and good, but you also would want to factor in things like taxes and cost of living. And so that's what my program does, is it takes initial salary expectations. This time I did entry-level software developers and mid-level software developers, although I could just increase the list that it inputs to include other disciplines or levels of skill as well. It takes that salary and then it takes your tax bracket by state and federal taxes out, and then it assumes your cost of living by state, which is grabbed from an index, and then goes through to find out what amount of money you're going to have left after taxes, after cost of living. So you can call it the amount of money to invest, salary, revenue. I think I use the terms interchangeably throughout the thing, but let's get started with a little overview of the code, and at the end I'll demo it. So initially I have two salary files. So these were painstakingly manually entered. So it features the state, and then afterwards the salary. Got another one for mid-level, which is salaries too. And then we have cost of living, which is based on an index value. So if you're above 100, you're more than the average, and if you're below 100, you're less than the average. You would want a lower value, which is why you see places like Hawaii having a really high value. And then places like Oregon aren't that bad. So from there, you take the salary that's read from the file. That is read over here. We're going to say, do you want mid-level or entry-level? 1 refers to entry, 2 refers to mid-level, as you'll see when we demo. And then it will read the file, and it will grab all the salaries for specific states, and then append those. So from here, it then runs into a function that takes out taxes. So we have for every state, we're going to give its state tax rate as well as the federal tax rate to get the amount of money afterwards. Those functions are up here. So for instance, federal taxes are pretty easy. It's just tax brackets. So if your income is between a certain number, you just get taxed a certain percent. Piece of cake. Anyone could do it. But when it comes to state, it's a little more complicated. So the information was gathered online. Some states don't even have state taxes. So Alaska, Florida, Nevada, New Hampshire, Wyoming, Washington, Texas, Tennessee. They're not going to have any taxes. Some of them just have a flat rate. So Arizona, Colorado, Georgia, Idaho, etc. And the rest are going to have a variable tax rate depending on your income. And so if you exceed the maximum, you pay the maximum tax rate. Otherwise, it's based on a formula. I assume all the formulas were linear. I'm not very well versed in taxes, but I assume just so many dollars, you move up so many percent tax rate, which even if it's not the exact way to do it, the tax brackets aren't that, they don't vary that much. Like it'll be like 2% to 5%. I think the most is like 11%. Variance from bottom to top range, so it's really not that bad. Afterwards, once we have all the taxes in there, and then the cost of living, we're now going to order states by economic viability. And by economic viability, I mean the state that has the most money left amount of money left over after taxes, after cost of living, is going to be your most economically viable state, whereas the inverse is true as well. If you have not a lot of money left over at the end, we're going to say your state is not very economically viable. So again, you would expect states like California, Hawaii to be less economically viable than states like Texas, Wyoming, things like that. So, because there's just higher cost of living, even though the salaries might be higher. Like, that's a big thing in California, San Francisco, where you see really high salaries, but it's really expensive to live there. So, we order by economic viability, and then from here, we're gonna take the dollar amount left over, and we're gonna convert that to an RGB value. So, let's take, for instance, our worst state. Let's just call it Hawaii. That state's, you'll say you have like $5,500 left over after taxes, after cost of living. That state then will be the absolute bottom, will be the 0 point. From there, every state is going to be some X amount of dollars better than that worst state. So the best state will be some amount of dollars better, and that final state will be the maximum green value, and the initial state will be the maximum red value. So if Hawaii is the worst and Wyoming is the best, Hawaii would have an RGB value of 255.00, where Wyoming would then have a RGB value of 0.255.0. The blue is only 0, but the red and green values are going to be inverses of each other. So if a state has 100 as its red value, then its green value will be 155, which we'll show in a bit here when it's demoed. And so to find the formula, you just subtract the minimum value or the minimum state salary, or revenue or profit rather, from all the other states, and then you just make a calibration curve to say if you're only like $100 more, you're gonna be really close to fully red, and if you make several $1,000s more, you're gonna be really close to fully green. It's just a pretty simple equation I did in Desmos, and then convert that here. So subtract minimum value from everything, take the max minus the minimum divided by this. This is going to be your slope, and then you're just going to put it in there, easy peasy. And then we're just going to sort based on the amount of leftover, which is then going to sort essentially the RGB values. I think it's actually the green value that's sorted, and then the red's dependent on the green value, if memory serves. Yeah, see right here, red's dependent on the green value. From here, we draw every state. And so this is the most painstaking part. This project's about 2,000 lines of code, and most of that is drawing this from 1733 to that. So at least 1,400 lines is drawing the state. So what happens is the turtle's going to come on in, and then it's going to be, we're going to set it to face a direction. So let's say due east, and then we're going to say go forward a certain amount, go right, go left, or set your heading to south, west, north, or east, and then go a certain amount and just repeat. So let's look at a simple state like Colorado, for instance. This state is going to have, we just set it the heading to east, which is the 0, because it's like a unit circle, it's just the degrees. And then we're going to move forward 140, go right 90, so now we're headed south, go forward 89 units, then go right 90, so now we're headed west, go forward 140 units, and then we're going to go back to the starting location. I could have also just done go right and then up 89, but this is just a simple way to end it every single time, so that the turtle goes back into the original starting location, and it was a lot easier to debug this way, especially when we get into more difficult states, like Alaska, for instance. You could just see how it gets really tedious to draw, and I could have circumvented this by drawing every state as a hexagon, but it felt like cheating. This drawing, you'll see, is fairly detailed, but not incredibly detailed. Like rivers, for instance, you're not going to see them in high detail or anything like that. It's just far too tedious. I mean, it was a 1,400 lines even without any more detail, so I think it's good. anyways, the function call for each state is going to have a couple of parameters. For instance, location. It's also going to use size, color, and text. So location is just an XY coordinate on the turtle screen that's going to open up. The size doesn't really matter. It was more of a thing that was implemented from another project I was working on, and then I just didn't exclude it. It doesn't hurt it at all to have it as an input parameter, but it doesn't really help it much. Yeah, the only thing it does is it sets the location of the text, so the two-letter code. For instance, Illinois would be IL, so it would throw that IL, then I can move that into a different location. But it's not really necessary. It could be cut pretty easily and have the same functionality. I just have to alter all the XY offsets for the state codes. But I'm going to need the state codes when it comes to drawing every function, so that the actual letters that I want for every state go into the actual thing. This wouldn't be a problem. I wouldn't need to do this if I were to draw them in a specific order, so like say alphabetically. But because I draw from worst to best, I need to update on it automatically, which requires me, as far as I know, to do this with dictionaries is the easiest way I could think of. But I'm imagining if I were to use object-oriented programming, it would be easier. Perhaps I'll revisit this in the future and see if I can do it a little better. But right now this is fine. Likewise, the starting location for the states, I also have as a dictionary. So these were found by just picking a random value, say like +100, +100, and then just altering it. So let's say it's way too far east, I would then subtract maybe 100 from the x-axis, so now it's 0, 100, still too far east, maybe -50, 100, and now maybe we're in the sweet spot, right? So I have a lot of weird integers because there's a lot of making it pixel perfect, spending a lot of time trying to perfect this before I actually shipped it out, so I hope you guys appreciate that. For the state abbreviations, this is another one that was just useful when it comes time to call a function. Okay, we're almost there, almost at the demo. I know you guys have been waiting. So, setting up the turtle graphics, we're just going to grab the screen and set the background color. You don't need to set the background color, you can leave it as white, but I think it looks a little nicer. We use a hexadecimal code instead of saying, I could set the color to like gray, but if I want to get higher, I would have to use, or like a lighter gray, I'd have to use it to hexadecimal code because it's just the easiest way to do it. There are like 2, 3 higher shades of gray that I could use, like more white shades of gray, but this is plenty, as you'll see. Alright, so we're going to introduce our turtle, and then manually introduce a window width and window height, just because the states, the bigger the window, the bigger I can draw them, and 1200 by 800 was kind of a sweet spot between I can show enough detail to where small states like Rhode Island or New Hampshire, I can still draw them, but they're not like so big that they just look a little awkward. Another state that's like this, Delaware. It's really small, but if you're gonna make it bigger, it looks a little awkward. So, and then we're just gonna set its speed to 20. So the initial turtle speed is painstakingly slow. Anyone that's used it knows this. If you try to draw anything large and complex, it takes forever to draw it. And I demo it here, but we'd be here all day. So I'm setting the speed to 20. I'm not sure if there's any higher speed than 20, but this speed is pretty close to the maximum. As you'll see, it's pretty necessary. We're going to hide the turtle because I'm only showing the cursor, even if it looks like a turtle. We like that. And we're going to pull the pen up to start because the turtle starts at 0, 0. So if I were to draw the first state at -100, +100, then it would have like a black line leading there. So just to clean that up. And then we're going to set the color mode to 255, which means instead of just setting the turtle color with like a string, like white, red, blue, magenta, we're going to instead set it with RGB values like the rest of the code is already set up. So you can actually see every state that's drawn. It's going to be drawn with a specific color that corresponds to how economically viable it is. So when it comes time to draw the gradient, which just gives a little sort of a legend as to how economically viable something is from worst to best. You can see all the shades from green to brown to red. It's just a little useful, but because that one draws so slow that even with turtle speed it takes like upwards of a minute, I'm just gonna cheat a little bit and set this to tracer so it instantly draws. That'll draw the gradient, which I could go into, but it's not really necessary. You'll see there's also turtle properties for drawing every state, but it's really just boilerplate code for turtle. And then we're going to use a main loop, which would turn on. If I were to comment this out, then it would immediately go into the last part, which shows the bar graph, but we're going to leave it run and then manually close the window because this isn't like a test of itself. I'm just trying to demo the code. So for the bar graph, it's going to basically take the state and then it's going to assign it its red and green value, and then the height of the bar is going to correspond to how much money was made, like the revenue, right? So salary minus taxes minus cost of living, this is how much money is left over. We're going to see all of them from worst to best, and we're also going to see pretty easily how that changes the color. Perhaps I should have called this function first, now that I look back on it, but it still is pretty neat to see just afterwards. So we are going to make a color index list, and then we're going to append the RGB color, which is just going to be decomposed into, or composed rather, of the red and green values, because we always leave the blue one blank, and then just some boilerplate code to actually plot it with a little bit of extra readability. I had to go into the documentation to find this because it was super tedious. It was very scrunched otherwise. So now, you might have skipped until this point. Here's the demo. So we're going to start, we can do entry level or mid level salaries. So we'll start with the entry level first, and then it's just going to start drawing. So you can see that it started drawing Hawaii first. I was mentioning earlier how Hawaii is the worst state economically, from an economic standpoint rather. So that's why it's drawing that one first. And now it's just going to go in order, drawing from worst to best, which is why all the colors are becoming more green. As you can see there, the last state, if you caught it, North Dakota, was the most economically viable, and therefore its RGB value is over here at 0.2550, where the worst state is Hawaii, closely followed by California and Florida. West Virginia is up there. Those are going to have RGB values of 255.00, or the Hawaii will, and then the other states are going to have ones that are really similar. So Florida might be like 4.251.0, but it's pretty close. And we can see that by closing this window and seeing the bar graph. So here you can see that Hawaii is the worst by a small margin, but it's still Hawaii and Florida are a couple thousand, 3,000 or 4,000 below even California. West Virginia's low, and then it starts to move up. And so you can see from red, you get this like brownish orange into brown, into a brownish green, into dark green, into very light green. And so this is, like I said before, this is just for entry-level salaries, but we can also do this for mid-level salaries. And so we'll just run the code again. Clear it. Just run it again, and this time instead of doing 1, we're going to do 2, which will grab us the second salaries, which are going to be higher because they're mid-level salaries. So we can see how it develops as you start making more, which will put more emphasis on the tax brackets and less emphasis on the cost of living, because the cost of living is a flat amount, because I'm assuming your quality of life doesn't change as your salary goes up, which is a bit of an oversight, but I digress. So this time you can see West Virginia was drawn first, and then Hawaii. So we can already see some difference here. Another difference that might be a little stark is there's a lot more states on the darker end than there were before. And this is skewed this way because the most economically viable state, which is second, Wyoming, is a fair bit higher than the rest of the states. So if we have a huge jump in that last one, whether it be the worst state is 5, 6, 7 grand lower than the next best state, or if we have the highest state is say like 10 grand higher than the next best state, then we're going to see everything kind of skewed that way. So let's take a look at the bar graph, and this is what I was talking about. While most of it trends normally, Hawaii and West Virginia are a fair chunk lower, like 5 grand lower than the next, and about 10 grand lower than the first big grouping. And then we can see that Wyoming is 8, 9 grand better than the next best state of Indiana, which is why it's skewed in such a way. But this is a really easy to read bar graph as to how the color changes with the annual profit. So that's everything for the code. There are a couple of things I would improve if I could. For one, when I was drawing the states, I was jumping around a bit between set heading and just rotating. I would now start everything just using the set heading function. I would rip out the size from the function calls that's not necessary, and then I would look into object-oriented programming to perhaps condense this 3 dictionary chunk here into maybe one sort of dictionary of objects, although it's a little out of my realm. So for now, I'm pretty satisfied with this. I don't think there's much I want to change to it. Like in the long term, I'm probably just going to leave this, but I just want to give some more insight as to how the code runs, and just the project is all. So thank you guys for watching, and I hope you have a great rest of your day.